Hi guys, in this video we are going to discuss an easy question, not an easy but a question from kinematics of particle. I have already discussed many questions from kinematics of particle. I have given the links below because I have discussed some theory areas and some main ideas to tackle any new questions. So just please watch those videos before watching these videos. So I hope you will like those. So I'm going to read the question now. I have given an image over there, so just copy that. After that I'm going to read that. Just listen and try to do that in your own. After that, watch the rest of the video. So here a racing car Q is moving at a constant speed. So this is Q. So a racing car Q is moving at a constant speed of 150 km per hour along a circular track of radius 300 meter. So and the center O as shown in figure. So I have given that. The car is being filmed from a camera mounted on a tripod at the fixed point P as shown. So this is the point of P. They have mounted a camera here. So it's going to film that car. So it's like a movie. So the actual point is we need mechanics in the movies also. Just know that. Yes. So for this instant, oh sorry, there I have missed part. At the instant depicted in the figure, theta is equals to 30. So for this instant, determine the velocity, angular velocity and angular acceleration of the camera so that the image of Q remains centrally positioned in the viewfinder. So the main thing is they are asking about the angular acceleration as well as angular velocity. We need to turn this camera, so from that we can directly film that car at the central position of the viewfinder. So that's the question. So I hope you can do this and try this in your own. So just pause the video and try it in your own. If you don't get any ideas or even don't know how to tackle a simple question, just I have given the links in the below section. So just watch that so you can get a clear idea about this. After that, try this question. Okay, let's do this together. So I'm not going to simplify those answers, but I'm going to tell how to do this. What's the idea behind this? Just write together. Okay. So when we are considering about this, actually we don't know. They have asked the radial direction, acceleration or velocity. They haven't asked about that. They are only asking what's the angular acceleration as well as angular velocity. But we all know to figure out those values, we can't directly find that. The main thing is we should do is we need to find the radial acceleration along this as well as transverse acceleration along this radius r, as well as the velocity towards the center or radial direction velocity as well as transverse direction velocity. So before that we need to find those values. After that only we can find for theta dot and theta double dot. So that's the main idea. So we need to find those basic equations. So in the previous video also I have just jotted down those equations. After that only I have tried to solve that. So that's the main point. However, we don't know about this radial direction acceleration velocity or transverse direction acceleration velocity along this axis, but they have given some data about this O axis, about this OQ. Let's consider this OQ as a rod. So what's happening here? So we can directly tell it's going to rotate in this circular path because they have already given this is a circle. The car is going at a constant speed because the direction is going to change over here. So that it's at a constant speed 150 km per hour, as also it's having a circular path. So that's the main idea. So here we can directly tell once you see that it's a question from a circular motion, simple circular motion. So you can directly tell the acceleration towards this O would be in this side. It would be equals to r omega squared. or in other terms we can tell v squared over r, because we are having the velocity. I am going to change it as v squared over r, so it's not a big deal. So it's kind of a simple rotational motion, and in this direction we know the value of velocity, but keep in mind that we are taking the point of view from this OQ, as it's having only the rotation, only the simple circular motion. We can directly tell it's going to have the acceleration, centripetal acceleration of v squared r over r, and the velocity a constant speed of 150 km per hour. The main thing is we need to find from this PQ. So how are we going to find that PQ value? It's similar to the first question we have done in this kinematics of particle. So we need to find the velocity and the acceleration in this direction. So we need to divide this, or we need to find the components of this in this radial direction. That's the main idea. So which means the velocity of the car in this direction, in the radial direction from the PQ. Why are we finding that? Is we need to find the rotational angular velocity as well as angular acceleration from this P, from this camera. We need to find for this. So we need to find what is the radial direction velocity and transverse direction velocity along this. So that's the main point. After that, we need to find what's the acceleration along this and this transverse direction. But I have already mentioned the particle is having the velocity at this direction 150, and the radial acceleration would be in this direction towards the center, because it's having a simple circular motion. So just we can directly find, by this is 30 degree, we can get the component over here and find the radial acceleration. So let's start from this 90, and this would be 60. If we find the value of BR, so radial direction velocity from this PQ, just remind this, we are going to find for this PQ. I have already mentioned why we are finding for this. So that's the main reason. We need to find the angular acceleration and the angular velocity for P, for this camera. So we already derived that VR is going to be equal to V cos 60. We already know this is 150 km per hour. So 150. It's better to change this to meters per second. So for changing to meter per second, you can directly multiply by 1000, 150,000 over 3000 divided by 3600 second. So you will be getting answer around 41.1, I guess 41.1. So just I'm going to simplify, I'm going to use that value. So also I'm not sure about that. After finding these values, just comment it below so I can also check. Others also can check with your answers also. You can become a famous celebrity. Yes. Okay, I'm going to put this velocity 41.1 into cos 60. So we all know the value half. So we can directly tell in the radial direction this velocity would be this value. As well as we can directly tell what's the value of BT in the transverse direction from the PQ axis. It would be V cos, this would be 30 degrees, so V cos 30. So 41.1. If there is any mistake, don't bother anyway, just comment it below. I will also check that. Yes, 3 by 2. So okay, after that we need to find the radial direction acceleration. So when we are considering the radial direction acceleration, that's the main point we should note over here, because here we have given the acceleration is towards this, which means towards the center. So when we are considering the component of this along the radial direction, it would be in this direction, which means negative sign, because opposite to the radial direction of PQ. So when we are considering this V squared over R, we need to find the value of V squared over R. Keep in mind that we need to change it for 41.5 meter per second. After that we need to find the R. Use this 300 meter, not this R, because when we are considering this circular motion, this is the radius of this circle. From that we can find the V squared over R value. After that we can find b squared over r cos 30, but remind you need to put the negative sign because it's inside this. Okay, after that what we are going to do, so we can directly tell transverse direction acceleration would be in this direction, so it's not a problem because we are always taking as in this direction, which means in if the theta dot is in this direction in the anti-clockwise, we can directly tell we have already derived the equation A transverse in this direction. So b squared over r cos 60, and it's going to be plus b squared over r cos 60. So we have already found this. So how are we going to find the alpha and the theta dot? In other terms, we can tell theta dot as omega. So they have asked about that, but I have already mentioned for finding those we knew that we need to get some equation along for these 4 components. So how we are going to find the value for alpha and theta dot? Actually, I also don't know what the method is, but the idea is we already knew for VR would be equal to r dot. So I'm going to change it for r dot and theta dot. Why is that? As we all know, when we are considering the theta dot or theta double dot, first of all we need to know what are the values for Vt, which means if I consider Vt, it would be r theta dot. If we know the value of r over here, which means this r value, we can directly substitute and get the final answer for theta dot omega. So that's why I'm going to use this. So if we have already found for Vt transverse direction velocity, but we all know that Vt would be equal to r theta dot. From that we knew the value for r at the instant of theta is equals to 30 degree. From that you can find the value of omega by dividing this value by r. So that's completed. Okay, at the next step we need to find what's the angular acceleration, which means theta double dot or alpha. So when you are considering about the alpha, the main thing is where we are going to get the alpha sign. So for radial direction we already knew that would be r double dot minus r theta dot square. So we don't need that because they haven't asked about that. They are only asking the angular acceleration, which means theta double dot. So here the at would be r into theta double dot minus plus 2r dot theta dot. So this would be the, we need to find the value for this theta double dot. We can find this. How to do that? Just we knew the value for at transverse direction acceleration. You need to calculate by this 30 degree component, in this 60 degree component along the transverse direction of p cube. After that we knew the value for r in this direction r, as well as if you are considering the r dot value we have already found. Vr is this, we need to simplify that. From that we all know what's the value of theta dot. Here, yes, we have found this in this step, theta dot. So once you substitute this and solve this, you will be getting an answer for theta dot and theta double dot. Hope this video would be useful. Just do these sums and leave the answers in the comment section, so it would be useful for you as well as others too. Thank you for watching. Thank you.